And we're live. Welcome back to another Corona Geek here, where we talk all about mobile app development using Corona SDK. I'm your host, and today we are going to talk about rotating around a center point, and we're also going to talk about Coronium game server without the game server. We're going to talk about Coronium Sockets, which is a brand new addition to the Coronium family from Chris Byerly. So joining us on the panel is Chris Byerly. Hey, Chris, how you doing?
Good, thank you.
Also joining us is Ed Marina from RoamingGamer.com. Hey, Ed.
Howdy.
And Greg Pugh from GP Animations, who is facing a foot worth of snow in his future. Is it already or coming in the future?
I think starts later tonight, ends on like Thursday night or something like that. I don't know.
Get your plow shovels ready.
Yeah.
All right, so we've got a lot to talk about today, so we want to jump right on into it. But first, we have a couple of announcements. One is, if you didn't see last week's show, that was number 118. We talked about shuffling Lua tables, shuffling items in Lua tables. We talked about widget themes, and we talked about variable function arguments. So if you didn't get a chance to go check that out, go do so. It's a good watch, and you can find all of the videos over at youtube.com/Corona Geek. That's a good place to go. Also, if you are looking for resources for learning Corona SDK, if you learn well by going through examples, then you want to go over to burtonsmediagroup.com. Dr. Burton's created a bunch of resources over there, several books on Corona SDK, and he has generously provided us with a coupon code of Corona Geek. If you use that at checkout, you'll save 20% on your purchases. So be sure to use that coupon code when you go over there and check out his books. He's got lots of great stuff. You can copy paste the code right from the book, and it makes a great resource for any type of development that you want to do. And it's all project based, so you can kind of look at examples from end to end and get a good idea of how things work and what they're doing. Also, have you guys heard that Fun Run 2 is out? Have you been keeping up with those guys? They had, at least on their website, they posted they had 45 million players worldwide.
Yeah, I've seen a couple videos about it already. Let's Play.
Yeah, so they have Fun Run 2 is out. So if you haven't checked that out, go check it out. You can customize your character. You get to run around. It's a little more. What's that? Bloody? Yeah. Well, the kids like Happy Wheels and all those types of games, and this kind of just falls right in there. Anything that's gooey, gory, whatever kids are gonna like, and it seems to be doing very well. So go check it out. It might be interesting just to study just from the as far as collaborative gameplay and being able to mix up your characters and just having fun.
It's got also a multiplayer element to it. Sorry. Yeah.
Oh yeah. It's got a multiplayer element to it, which makes it fun. I think that's the community aspect of it. I think that makes it a collaborative thing. So, have you guys seen Dumb Ways to Die? Dumb Ways to Die 2 is out.
You missed it.
Yeah, you missed that one. What's that?
No, I must be cutting out on your side. I said, how could you miss it? But I watch a lot of. I have subscriptions to a bunch of YouTube channels for Let's Plays because I'm always curious to see the latest video games, and I don't always have time to play them myself, so I watch somebody else play them.
Gotcha.
I know it's South Park, but hey, have you seen that episode, by the way?
Which one?
The South Park rehash.
No.
No. Go watch. No. Go look up South Park rehash.
Okay.
You'll see what I'm talking about.
All right, I will do that.
Further.
Yeah, is the Dumb Ways to Die showing up a lot on the trailers and stuff? Is it all over the place?
No, I mean, yeah, sure. It's been around. It's been out for a while now, and I've seen a lot of Let's Plays against it.
Yeah. So I have the original app. I have the one or the original version, if you will. But Dumb Ways to Die 2 is out, and that's not a Corona game, but it is a Fuse-powered partner, so they're monetizing it and things like that. So, which is kind of cool. And also, congratulations to Ray Delia from StinkyKitties.com for being November's Geek Games winner. He won a $50 gift card for playing Dr. Spin and having the high score, and so congratulations to him. And now this month, we're going to play for December's Geek Game. We're going to play City Birds or Vritra, V-R-I-T-R-A. Have you guys seen that one? It's like the old school arcade shoot 'em up. It's a great game. It's like action-packed, fast-paced, lots of explosions. Anyway, we'll put a link in the show notes, but we're going to play both of those games. City Birds is only on iOS, and Vitra is on iOS or Android. So we're going to pick 2 winners this month. We're going to have 2 gift cards. So if you want a chance to win a $50 gift card, then all you have to do is play either one of those games, post your high score to the Corona Geek Facebook wall, and then we'll pick a high score winner at the end of the month, or 2 high score winners at the end of the month. We'll do that at December 30th. We'll pick the winners and announce those on the show. So check the links in the show notes for that. And I think that's it for announcements. Did you guys have anything you wanted to talk about? I mean, before we talk about what you're going to talk about? Nope.
Sorry.
No. Okay. Ed's easily cracked up. Okay. So Ed, tell us about rotating around the center point.
Well, as you know, I keep track of questions in the forums, and I like to snipe a few questions every once in a while and try to answer them to the best of my ability. And so I saw a question in the forums where the person said the gist of it was, or the thrust of it was, is they wanted to rotate an object about some point on the screen, and they wanted to use transitions, but they couldn't get it working. They were having trouble figuring out how to make it look right. And so I said, all right, well, using transitions, that's the elegant way to do that, but there are things you have to understand about transitions. And so I quickly coded something up, and I said, well, this is good, but as I usually do, I said, well, okay, that's the one case, the full rotation, but what if I want to do a partial rotation, or let's say if I want to change the speed halfway around the circle, or if I want to do multiple rotations. And so I said, well, I already know how to do this, so then I coded something else up out of my library of code. I grabbed code from here and there. And long story short, I put together an answer and posted it to the guy, and then you said, guy or gal, actually, I'm not sure, and then you wrote me and asked if we could talk about this. So I put together 3 different examples, 2 of which use transitions, and then, well, actually they all use the transition library, but the last one is my sort of like super rotator dealy bobber. I don't know what you'd call it, but the more, not so much elegant, it's less elegant, but more capable solution. So let me just jump over and show you my screen here.
Yeah, I saw this on YouTube. You'd shared it out as a silent film.
Yeah, I try to, whenever I answer something where there's a visual element and something, it's hard to sort of like describe it, I try to give a video so people can say, aha! And the other thing is you put a video link, and immediately it draws in more viewers on the forums, so people are like, oh, how'd you do that? So, if I'm going to answer a question in the forums, I try to get the most bang for my buck out of that as far as viewership and people remembering, oh, yeah, that's what that solution was, or that's how it works. So what I've got here is you should be able to see my screen at this point.
Yes.
It's maybe a little bit bigger. This code will be available right after the show. I will commit it and give you a link, which you can include in the show links. But the example consists of a config file, which we don't care about, a build settings file, which we don't really care about. I've included some standard settings there. But the files you do care about are main.lua, and then what I'm calling attempt 1, attempt 2, and attempt 3. So attempt 1 and 2 are pure transition rotations, or what are supposed to be rotations. I'll tell you the problem in a minute. And then attempt 3, which is a little bit longer, is a transition-based vector calculated rotation. So the position of the object is done using vector math, and the transitions library is used to control the current rotation angle about which the object is being drawn. That is, the angle at which it is placed. I'll show you that in a second. So the person was trying to do this, and let me just jump right over. Oh, let me show you in the main, actually. In the main code, let me make this real big so people can see it in the video. What you're going to see here is 3 lines. Local rotate about equals require attempt 1, attempt 2, and attempt 3. And when you run this, just uncomment one of these lines. And what you'll be doing is using the rotate about function, which is defined in the named file attempt 1, attempt 2, or attempt 3. And they all have the same signature as far as the function goes, so they're called the same way. Yeah, so they're all called the same way, except that the rotate about from attempt 3 has more options. So let me go ahead and show you attempt 1. Let's talk about the code there first, and then I'll show you what it does. So in attempt 1, what we've got is a function that takes an object, an x and a y position, and then a parameters table. And we talked about this last week. What I've done is supplied a table where I allow you to parameterize various arguments, like the radius of the rotation, the time it takes to do the rotation, and then a flag called debug n for enabling some debug output. So all this function does, this is basically what the person was doing, but in a few more lines of code. What they were trying to do was use one transition to change the x position. Because if you think about it, what is a circle? All it is, really, is an object changing the x position and the y position over time. The trick is to get those x and y positions to approximate a circle. So what they were doing was transitioning the x from a center point to the right, to the left, and back to the center. And then they were transitioning the y from some point above the rotation point down to the center, or actually down to the bottom, and then back up to the top. And so when they did this, what they were getting, let me show you the code, let me run it. Try to run it. What's going on? Failure to run, hold on. Maybe I have it commented out. Yes, I do. So I'm going to go ahead and run this, but let me explain what these arguments are saying to do. So we're running attempt 1, and I've created a circle here and placed it at position 0, 0, and given it a radius of 5. Then I'm going to pass the handle to that circle into rotate about, and I'm going to tell it to rotate about the center of the screen, center x, center y, which I've defined up above here, and then use a radius of 50. In other words, it's going to be rotating about the center, and the circle that it's supposed to describe has a radius of 50. Furthermore, I told it to take 2 seconds to complete the rotation, and I turned on the debug code. And what the debug code is basically, if that's enabled, every frame it draws a dot at the position that the object is at, so you can see at the end of that 2 seconds the path that it took. Now obviously you wouldn't want to do that for your game, but as far as for this example it makes sense. So if we run this, this is what we get, which is not a circle. What we get is a diamond, or a square turned on its side. So this is where the person was stuck, I'm pretty sure. And the reason is because they've done everything correct. They did transitions where it went 1/4 of the way to the right, or over 1/4 of the time it went right, 1/4 of the time it went to the middle, another quarter it went to the left, and another quarter it went back to the middle. And then the y was calculated from the top to the bottom, taking half the time, and from the bottom to the top, taking the other half of the time. Everything was right, except one little detail. They used the default transition easing, which is linear. And when you use linear, it's exactly what you would imagine. It takes linear time to go to the right and to the left. What they really wanted to do was use the in and out circ easings, which is used in attempt 2. Let me show it to you. So this is exactly the same code, except when the x is modified over the first quarter from left to right, we use easing out circ. Then it will move in the next quarter of the period, it will move right to left, and we use in circ. And then we simply repeat that moving to the left am moving back to the right. And then we'll see, we simply require attempt 2 in main.lua, and we run this again. Now we get a circle. It's good. But this is not extremely flexible in the sense that we can only describe a complete circle. We can't tell it to rotate partway around. We can, but at the point where we say, let's say we want to do 270 degrees of rotation, starting at 45 degrees. To do that, it becomes extremely complicated to figure out what the transition X and Y positions should be, and applying the correct easing is almost impossible at that point, because the easings aren't really designed to be doing this. How do I describe it? The circular output is a side effect of the mathematical calculations, but they're all based starting at 0. As soon as we want to start at 45 degrees and only go part way, everything starts to fall apart. You'll get a shape that is non-circular. So as I said, what I did was, having been doing this for a long time, I knew that the more robust way to approach this is using vector math. And so I wanted to retain the use of transitions so I could control the timing of the rotation. But other than that, I did everything else using vectors. And so I supplied to the person in the forums post a couple of functions for calculating, let's see, scaling a vector, which is taking a unit length vector and making it the correct length that for the radius that I need, and another one to take an angle and convert that into a unit length vector. So the way this works, takes the same arguments, and in here I go ahead and I add some default values for my parameters. For example, the radius is going to be, oh, it looks like I named this differently. I have made a mistake. Bummer. 2 seconds. Let me take a look at the code here for those watching. Yeah, let's go ahead and just change that to. Well, I'm going to leave it alone for now. Okay, so path radius, which was the name of the argument was supposed to be radius. I should have left it alone. For some reason, I changed it. 50. The default starting angle, the rotation starts at 0, and the ending default is whatever the starting point is plus 360, or whatever the so whatever the starting point is, or is plus 360 degrees. But we can modify both of these, so I could start at 45 and end at 90 degrees, or start at 0 and end at 720 degrees, which would be 2 rotations, or I could start at 0 and end at minus 360, go in reverse. The next argument is time. I use the default of 1 second for the time, but we can of course change that to whatever we want. And here's the beauty of it. Besides changing the starting and ending angles, is you can play with all the different easings that are supplied by Corona. And what this will do, I'll show you in the debug output, is we'll give you some really interesting rotation behaviors as far as the speed of the rotation and how much it rotates and rotates back, etc. And then there's the debug flag. So then we get into the heart of the code, and what it does is initially when you call this, it calculates the angle of the starting rotation. So let's assume that that's 0 degrees. So this would be the same as having a 0 here. And it converts that angle into a unit vector. Then I take that unit vector and I scale it by the radius, which is saying that I'm going to make a vector that is as long as the radius needs to be, but has the properties of pointing in the direction of the angle. And then what I do is I take that calculated vector and add it to the object's starting position, which is the value here. So the value that I passed in the x and y plus this vector will basically, what that says is as soon as you call this, it moves the object to the starting point of the rotation. Let's skip this part for now. The next thing that's important is the enter frame calculation, so the enter frame function. So what I do is I attach a listener, and every time enter frame is called, I will redo the positioning calculation because further down here I'm using transition to change the rotation of the object. You'll see that I've got this funny name. So it's worth noting that a lot of people, when they see transition, they think, oh, it's got to be a display object. Transitions are, the library is used to modify any field on a table or a display object. Well, display objects are basically expanded tables. They're tables with more properties, in a sense, to Lua, as far as Lua is concerned. So the transition library is used to modify a field over time on a table, which means that we can make custom fields on our objects or on tables and then use transition to change that value over time. So if we look at this code, what I'm telling it to do is I'm telling it to change this field path rote on the object, and I'm telling it to go from wherever it's currently at to this value, taking this long and using this easing for this transition. So then in my enter frame code, if you'll see here, I take this angle, which is being modified over time by transition, and I calculate a vector. I scale that vector just like I did originally, and then I add that new vector to the starting position of the object, or the starting, the center point, which is the X and Y represent the center point of our circle. So what you get, just skip right to it. Sorry, not doing a very good job. It's easier to show this than it is to talk about it. So let's go ahead and require attempt 3. And we can use this, let's just go right down here to the rotate example. So the default example would be to use all the default variables. Just start at 0, rotate to 360, take 1 second, have a radius of 50. And let me bring up the code so we can see it. And if we run it, I don't have the debug code on, but you can see there that it rotated around. Similarly, I can go ahead and pass in start at the center point, turn on the debug code. Let's turn this one on. And you can see it describes a circle. Or we can do more interesting things. Rotate about the center. Take 10 seconds to do it using an out elastic, which means it's going to, in a sense, bounce. It's going to pass the ending target, and then it's going to come back, and then it's going to keep doing this bouncing thing until it settles down, and then show the path. So we run that. And so as you can see, is it rotated around, but because we're using the out elastic transition, it shot past the point where it wanted to go, then it bounced back, and it kept bouncing, and you can see by the density of this debug output, the points where it was most often at during the enter frame. So this is just a nice visual way to describe the arc.
So it also gives it a nice organic feel.
Yeah, exactly. This is the beauty of being able to apply the transitions for the timing of the rotation, because you can get a nice, as you say, organic feel for the movement. It becomes a lot more interesting looking, a lot more juicy. If people listening remember that discussion a few years back from one of the game conferences where they were talking about making your game juicy by giving it little visual and audio effects to get people to enjoy the game more, basically to get a little more, what's the word I'm looking for here? I can't think of it. When you get into the game, somebody's going to write you later and say, Ed, this is the word you were meaning.
Engagement.
Yeah, well, engaging, yeah. So let's do another example here real quick, and then I can answer some questions, and then I'm going to be out of time. I want to let Chris get to his thing. So what are we doing here? Rotate about the center, takes 6 seconds, start at 270 degrees, end at -90, so it's going to go in reverse. and use the bounce. And again, show the debug. So let's go ahead and do that. And voila. And that's it. Not much exciting. Or we can do this too. We can do 270 to 90. Now it's going to go from here to here, I believe. And then we got half an arc. All right. Any questions?
That's way cool. Good job.
Yeah, I just like to, I see a guy out there trying to figure this out, and my guess is either he hadn't thought to use vectors at all, didn't know how to use them, whatever. And I thought, this solution's easy. It's a good step up for people to start learning about vector math, and they get what they need. So there I am.
Very cool.
I like to do that kind of stuff. You'll notice I don't answer the hard questions.
Low-hanging fruit.
I stay away from stuff like, how do I make this in-app purchase thing work, or whatever. Nope. Sorry, talked to the wrong guy.
Well, I tell you that the two takeaways that I have there. One is the transition to.
Mm-hmm.
That you can use it with things other than just display objects.
Right. That's very important.
I think that's a very important concept to hold on to. And then the second thing is just grab this piece of code and put it into your toolbox. Whatever you have a code repo that's local to your machine, or you use something like GitHub or Bitbucket or whatever, grab it, save it. Because even if you don't need it today, you can pull it up later and use it then. Because these are little nuggets, I feel like. I'm a code hoarder.
Yeah, me too.
I like to pull those little pieces together and put them in.
I have an electronic journal where when I see some cool code, I just put it in my journal and give it a title and then paste it in there. And then someday I might go back and go, yeah, I could use that.
Dear Diary, today I rotated around a center point.
I used let's look at my journal, my circle overlap axis aligned bounding box code. I don't even know what that does.
Do you use tags? Do you tag your stuff too, so that you like your stream of consciousness, so you'll be able to go back later and find something?
I keep a daily journal where I keep notes on the things that I found, and then I keep another part of my journal where I actually keep the code. So yeah, I do both.
Okay. And it's all searchable, right?
Yeah, it's searchable. Yeah.
I just have a huge folder full of code from the last 3 years.
I used to do that, but then I started losing stuff.
Yeah.
Yeah, it's a nightmare to keep track of lots of code.
Sometimes.
Yeah.
Well, there you go. Well, yeah. So grab it, keep it, and if you don't have a swipe file, if you don't have some sort of file for today that you keep, why not? There's a lot of great examples out there. A lot of free brain power that's being passed around.
That's right. Free brain power.
Well, thank you for sharing that, and we'll put links to everything in the show notes, of course, as always. And so, Chris, tell us about Coronium Sockets. What you said? You told me that Coronium Sockets are like Coronium Game Server without the game server part. So, what does that mean?
Basically what the idea was is to kind of abstract the socket server from the GS. And basically what it does is it kind of allows people to build more customized socket solutions. With the GS game server, I had taken care of a lot of the work behind the scenes as far as managing clients and games, etc. And so this kind of takes that away and just pairs it down to just a socket connection.
So Chris, I don't want to interrupt you, but just for anybody who's listening who may not be familiar with sockets, can you give us like the 30-second overview of that?
Yeah. A socket is basically a connection from it's a client-server situation where in Corona you can actually the Lua socket library, and that library you can use in Corona to connect to a server. And once you do this through sockets, then you have a real-time connection both up and down. So similar to WebSockets and things like that, it's basically a way for you to have high-speed transfer between your client and server. And in our case, that would be our Corona client. So the thing with the Coronium GS, it had a lot of hand-holding being taken care of in the background. There may be situations where you want to have a different type of configuration. It may not even be a game. And in those cases, I've put together Coronium Sockets, which again just takes that library out of the GS and kind of puts it into its own. With that, though, of course, you have to handle more of it yourself as far as building the framework. You could use this for, if you wanted to use it for a business app, if you wanted to use it for real-time analytics, things like that. Any kind of real-time or near real-time functionality. This also, too, is the Coronium Sockets provides a good way to kind of build a global connection. So where in the game server you would be siphoned off into different games, here everybody is just all connected together on the server. So it opens up different possibilities like global chat and multiplayer, bigger worlds where everybody is kind of involved at the same time, as opposed to little separate games. So what I wanted to do is just kind of show just quickly the connection and how it all works, and then just talk a little bit about how you expand it. This becomes one of the major questions, is how do you expand these things and build your own code base on top of it. So I just want to show a little bit of how that works. And I'm going to go ahead and just switch over to my screen share here.
Now, is Coronium Sockets, is that on a whole separate website, or is that someplace different? I mean, the same as Coronium Game Server?
Yeah, I don't have, the site will be up within the next couple days. So there is no site at the moment where you can get this. There is a code base, but I'm finishing up the documentation, and then I'll have a place where you can download this. So I can give you a placeholder URL at least for now.
Okay, so basically, if you're watching this live today or within the next few days, then you're getting a sneak preview.
Yeah, it'll probably be coronium.io/sockets. Probably that makes the most sense. There is no install or anything yet for this. Again, I'll have that all prepared, but this it's all ready to go and it's been tested. And I've been actually doing a lot of tests on the engine, which again, this is the same engine that the GS runs on. And I've been getting some pretty good results, so I'm going to keep doing those tests and keep hammering at it. And the most recent test, I was on a 256 megabyte box and 1,000 concurrent connections, all sending messages back and forth every 50 milliseconds. And it was about 75 was the server load, which is definitely pushing it. But at a 256 megabyte box, it's pretty impressive that you can get that many concurrent connections shooting that much data together. So next step is to throw it on some bigger boxes and do some larger tests. So again, just like GS, this has a server and a client component. The client component is for Corona. So there's just a basic project here that I have. And it's all event-driven. It's very similar to GS. So if you've used GS, then you'd be familiar with some of these. It's all just based on events, and you listen for these and take action appropriately. The server is also very simple. It's just a handful of modules, and then there is a very similar-looking main for the server. So it helps to kind of quicken your development because you're kind of dealing with the same kind of actions on each side, which is common with sockets. So I've already set up a server. I put it on, I think this one's on DigitalOcean. And we can look at just logging in. I have the IP address here is pointing to it. The Coronium Sockets runs on 8100. So we'll just go ahead and see if we have anything here. Actually, I need to open up my log. Okay, so as you can see here, this is some previous logging here. the server's running, and it's gone ahead and made its connection, and here's my ping coming back. And the ping is actually an event, so here I'm just putting some output here. The ping brings back the round trip timestamp, and so I'm just printing that out here as it comes back in. This is an event that is part of the client, as are these datas, connect, ready, etc. And these are just kind of the most common events. A socket itself is actually quite a simple beast as far as what its functionality is, but when you get into the little intricacies of it is where it becomes a little more complicated. But you don't really need to worry about that stuff that much until you start getting into massive amounts of clients, etc. So on the server side, we basically have a bunch of different events here. One of the ones that's kind of important is the client connect, and from here you get the client object, and you can start to manipulate that if you want to. Client data is where we bring in our data, and this can be sent up from the client. So on the client side, there's a on client ready event, which means that everything is all hand shook and taken care of. That's the other thing, is that the server itself does still handle a couple things. It handles the handshake between the client, and it also makes sure that the client's ready, and then gives you a message, the client ready message, letting you know that you can start to talk back and forth with the server. So what I'm going to do is on the client ready, basically once I log in, I'm going to get this client ready event here, and I'm going to go ahead and just, if I want to send data back to the server, it's extremely simple. In this case, I'm going to use client. Up here I pulled in the client module for this Coronium Sockets, and I've given it the name of client. And then here I'm going to use the method client send, and it always takes a table. So, and you can send any values as you need to. They just need to be able to be JSON encodable. So here I'm going to send up this message as soon as we log in. On the server side, I'm going to go ahead and we're going to get this on the onClientData event because I'm sending data to the server. Go ahead and just uncomment out this data thing here, and this will echo out whatever data is coming up into my console window. But I will need to make sure that I upload my server file, so I'm going to go ahead and do that now. And additionally, I have to restart the server, or the process, the Coronium Sockets process. So it tells me Coronium Sockets started. I just restarted, and then I'm going to run this, and hopefully when we get the onReady event, we should get some data up here. And yeah, we got the greeting equals hello. So just right there alone is shows very simply how you can start to talk back and forth to a server. On the main Lua here, I have this data coming here. If I just decided I wanted to send something back when I get data, what you get passed on the client data is the actual client reference as well as the data, which we just saw. So if I just wanted to echo this back to make a simple echo server, I can just do, again up here, client send, and I'm just going to push that data right back down. I'll go ahead and push this back up to the server, and we do have to do refresh. Start this thing here, and we got the greeting hello here, and if you notice down here in my client now, I also have greeting hello. So that was a round trip echo from the Coronium socket server. So now I have pretty much everything I need to, at this point, create an application using sockets. And there can be many, many clients connected. This is just obviously an example with one client. But anytime a client sends data, they're going to get back that data, but only that specific client. So it handles all of the client objects for you. One of the other things that is built in to the server itself is a broadcast. So let's say somebody did want to broadcast, this would be good for chat or something like that. You can use the sockets broadcast data, and that's going to broadcast this data to every client that's connected to the server. So that can be helpful as well. There's a few other things where you can get the client count. You can get the array of clients and iterate over them and do specific things if you want to. The client object also is where you can add in, you can basically extend this to add in your own functionality. And you would most likely do that on the client connect. As soon as they connect, you could add any type of functionality you wanted. So you could just add it right to it. So just whatever, do new username. And then you could just do equals function, blah, blah, blah. And then you would have that function available on that client anywhere where you can get a client reference. So the one other thing that's important is how you actually extend the server. And when we're in the server part, we're not in Corona anymore, but we are in Lua. But there's a few different things you have to do to kind of work with the server because it's event-driven. And this is what gives it the ability to handle a lot of concurrent clients and be able to service them all. And this is something that's part of Loveit, which is the engine it runs on. And Loveit is built from LuaJIT and libuv, which is a C event loop. So it's extremely quick. It's used in very high-profile applications, and so it's at the C level. So it's, again, very, very fast. But you do need to make sure that you don't do anything that's blocking. And a blocking function or something where maybe you're reading data directly, things like that are going to block this loop. So what you have to use is events. And by using the event emitters, you can basically do all sorts of neat things without blocking that loop. And that's what becomes really important when you're building these socket applications. So, for instance, let's look at extending it. A lot of times I like to, in here you're going to get a lot of different action if you're sending a lot of different data calls to your server. For instance, the way to really handle this is basically you're sending messages from the client up to the server, but you're going to need a way to kind of like know which ones are which. So in this case, if I wanted to send this, I'm sending greeting equals hello. Well, this greeting key here gives me the perfect opportunity to be able to kind of abstract what I need from this data and see what's going on. So I could do, oops, let me see, if data.greeting, and then I know that I have a greeting, so I could start to do whatever I wanted here. And so this, depending on the complexity of your application and what type of things you're sending back and forth, this can get quite lengthy. So what I like to do is to kind of create another data handler class for it. So, and this again is an example of how you kind of extend this. So I'm going to create a new file, and I'll call this the data handler. Save this. This would go in your modules folder for your server. And so this is specific to the server side. Everything we do, we use an emitter. And basically we extend this, this emitter object, which allows us to send and listen for events on the server. And then we can build in code appropriately. So again, this will be more documented. I'm just kind of going through it quick here. But I'm going to create my data handler class. It's basically just going to be extending this emitter. So I'm going to do that. And return data handler. And then I'm going to need an initialization function. So I'm going to do handler initialize. I'm not going to really use that now. And then I want to create an extra method that's going to consume my data. So data handler, and we'll just call it handle for easiness. I'll take in a data table that we get up. And then just for testing, I'm just going to print out this data when it hits there. So I've built this. This is the most basic form of an object that you use to add to the server based off of the emitter. Over here in my server now, I'm going to go ahead and let's go ahead and pull in this data handler. And we will just go ahead and create it here. We're only using kind of a singleton on this one, so just initialize it right here in line. So now I have my data handler, and I want to do something like handle to pass it data. Actually, I like to take the client too, because in case you need to send something back on the client, you can do that. So I'm just going to go ahead and change this. So I have a client reference if I need to. So if I wanted to send this back, this again is just basically an echo. And I'm going to send that back down to the client. And with that, I'll just get rid of that echo. So now we're saying, okay, if there's a greeting on this incoming data, send it off to the data handler and also pass the client and the data. I could just pass the greeting if I want to. And then we should see that echoed out here, and then it should also send it back. So this is a way of kind of abstracting that from here. So let's go ahead and make sure everything's back up. Oops. This is all on the main. And then we need to up our data handler. And reset the server. Okay, so let's see. We should get our greeting here and our greeting here. So that worked. So let's say the way you kind of use this main is kind of like a controller of sorts. Let's say I'm going to have a game class. And I'm going to do the same thing I did with my data handler. I'm going to create a new file. And this will be my game class. And we'll save that up. And in here, same thing. We're going to go with, we're going to extend this emitter. And we'll do a game. And that. Game. And we'll look at how you work with events. So I need to also make sure I put my initialization function here. Okay, so we have that all set up. I'm pulling that in here, and I'm initializing it there. We're just using it as a singleton. This is kind of like a general game handler. We could call it that. And so basically, what I'm going to do here is we're going to send this data to the data handler, and we're going to then create. Before that, we're going to create an event to listen for. This will be a data handler on. And we're going to call this one score. We're going to pass a score back. So do that, and so that we've built this kind. This is an event listener. This is based from the emitter class, and on. Basically, it's going to listen when it receives a score event. It's going to then run this function, and that's going to be also passed a score. And then we can just pass that to the game if we wanted to update score. This file becomes more of kind of the traffic cop of sorts, but we're still spinning this stuff out to these separate classes. So we get the greeting, the data handler gets called, and then we've also have this event that we're listening for, and when we get that back, we're going to update the game score. So let's go ahead and add our game function. Update score, yes, okay. So now in the data handler, what we have to do is we're going to look for a score variable. So we'll say if data table score, and we're going to send this up in a second. Then we're going to send an event out. So that's because this is an emitter object, I can use self, and it's emit, and I'm going to use the score event, and then I'm also going to pass the score value. So data table score. So this is just kind of a contrived example to show how to use emitters and events. So basically what's happening here is I'm going to actually take this greeting thing out. We're not going to use that. What's happening here basically is data is coming in from the client, which we'll send up in a second. This is going to handle the data, this data handler. It's going to be looking for the score key, And if it finds it, it's going to say, okay, I found a score key. Let's go ahead and emit the score, and here is the value of that. And then back here in my kind of controller here, when that happens, then it's going to call the game update score. And what's nice about these events is that game doesn't need to have any idea about the data handler itself. It could be anything. The update score method is completely on its own. And then, of course, you can add other things here, too. If you had other objects, let's say you had a UI object or something that you wanted to update, you can just add that there. And then every time you get the score event, you can update all of the different objects that you need to based on that score. So that's kind of handy that way. So we got all that in place. So on our main client, this is, again, back on our Corona here. I'm going to go ahead and we're going to send it on the client ready. We're going to send the score up. 1,000. And then again, once that goes up, that should get the client data. We're going to pass it to the handler. Handler is going to call an event. It's the score event. The game update is going to run, and then hopefully we should get this output. So let's update this here. I save my game at. Oh, okay, well. Go ahead and throw that up there. My game's over here. And then let's throw the main up. Reset that. And then let's run our client, see what we get. Okay, so we did. We got our 1,000. So it made that trip, and it called those events, and got back to the main Lua here. And this is basically all you need to create an application using the sockets. So now that you have everything all connected and whatnot, you can use the emitter events and kind of create your code base as far as how you want to deal with it. And again, we need to rely as much as possible on these events because that helps keep the server running fast and keep it non-blocking. So I'll definitely go over more of this stuff over time and create tutorials. But this Coronium Sockets is kind of neat because you can create pretty much whatever you want in the socket land. In this case, we could have a big multi-user game or whatnot. So that gives you a little taste of the Coronium Sockets.
That's awesome. So, Ed, do you have any thoughts or comments there?
I do have a small question.
Mm-hmm.
When you say sockets, your sockets are UDP or TCP sockets? I'm going to guess UDP.
Yes, TCP.
Oh, TCP, really?
Yes, TCP.
Oh, excellent.
I'm not trying to hit like real-time stuff. I'm doing near real-time, and the thing is with UDP, there's no trackability. They just throw
no reliability.
Yeah, throws data out.
Goes right in the name, unreliable.
There you go. Yeah, they're just throwing out data, and you're getting it sometimes and sometimes not. So I like the TCP just because you can count on it getting there.
Not just that, but you can get the ordering is important.
Of course, yeah, absolutely. Yeah. And with turn-based kind of stuff, obviously that's like critical. So.
Right. Or if you want to move part of your game logic to the server code, it needs to be getting the inputs in correct order. Otherwise, you're host.
No, it's neat. There's a couple people making some games on GS, and I've been invited to test one of them, and it's cool. It's working really good, so it's pretty neat stuff.
So yeah, I'm even more impressed now. 1,000 connections with UDP, I can see that, but 1,000 connections with TCP is a whole nother,
It's this libuv. It's the C library that it's kind of the Node uses it as well. It's event driven. It's neat stuff.
It's cool. Awesome.
Yeah, they used to have the C10K problem. Now it's the C1024K problem. It's can you get up to 1 million connections? And I guess people are doing it. So.
Wow.
It was like 40 gigabyte servers. But
yeah, I wish I had that problem. 1 million connections on my game. Oh, it's such a problem.
Okay, let me ask you a couple of questions. One is why do you choose Lua for all of your stuff? Right? I mean, you've got Coronium IO, Coronium Game Server, and now Coronium Sockets. So what's besides the simplicity maybe of Lua, like it's easy to work with. What are your thoughts there? What's your choice for Lua?
Well, definitely the simplicity, but secondarily is these tools I'm trying to create to kind of work with Corona. So my idea is, and this is how it was when I worked with Flash, is that I like to not have to have two different styles of code on the server and the client. I can move much faster. I mean, I don't know if I'm sure you've done multi-language development. It's like you're in JavaScript, you're hitting the wrong buttons, you're hitting the wrong, you're not, doing what you're not.
Brain malfunctions over time.
Yeah. So that was one of the things is I think people using Corona, they're investing in Lua. And so I think that helps. And additionally, it's just I did a lot of PHP server work, and Lua is just much more fun and easy and simple, and the libraries that are available are pretty cool. There's a lot of good stuff out there. And it's shown, especially Lua JIT, to be extremely fast.
Yeah, I like Lua because it's got all the fundamentals, but it's clearly missing some of the more advanced features of other languages. But you know what? I don't really miss them that much for the fact that it's so easy to use.
Yeah, it just the learning curve was slight, and then it's for me, I understand that there's not like any typing or anything like that, but for me it's like that's my responsibility. I make sure that my code does what it's supposed to do. I don't need to constantly go through.
I think the speed comes out of that, right? Because you're not relying on something where it's executing a lot of code to do a little check that you should have done in the first place.
Exactly. Yeah, I think it gives the programmer more responsibility personally. But, yeah.
No, okay, so the other question I had was, I haven't spent a lot of time working with sockets personally, but there may be some people who are interested in the concept, especially since you've gone to such lengths to make it approachable. Especially everything we just saw is very human readable code. I mean, it was easy to follow, even if you didn't 100% understand what sockets could do for you. Is there a primer out there that you recommend that would help people with the concepts of sockets, or is it, is there nothing like that?
I mean, yeah, there's obviously varying degrees of information out there about sockets. Again, I think that a lot of times people maybe make sockets out to be some type of weird, mysterious thing that's hard to handle, and it's some special science, but it's not really. It's the same thing as basically. I mean, you're using sockets in your web browser. It's just they're not staying connected. They're just hidden and then coming back. And in this case, we're talking about sockets that are keeping a consistent connection, so a persistent connection. So
Gotcha.
it's just the data. It's just a data pipe. It's the same pipe you're using for anything that's happening in your computer when it's leaving your network. So.
Okay. Are you an Elton John fan?
Well, my wife is. Does that count?
I was going to say, can we start calling you Socket Man?
Socket.
Socket Man!
I knew we were going there. Rocket. You're fired.
I'm fired. You're fired. Well, thanks for sharing that with us, and thanks for spending all the time on it. As always, I mean, I'm looking forward to seeing the documentation and all that you produce, because it's always top notch. And is there anything else that's in the wings? Anything else that's in the pipeline that you think you're going to approach?
The only thing that I'm hacking on right now is Coronium PI. That's my Raspberry Pi initiative. I've already been having some neat luck with that, with the GPIO and a couple different the different bus classes. There's a bunch of ones built in Lua, so it's kind of neat. And that's just using a smaller event library, but that one's fun. And then I don't know if I said it, but there's been a major update on the GS engine. So if anybody is using it out there, make sure you do update. You can go to coronium.gs and do that. Yeah, there's a critical fix that's just really increased the throughput. So it's a much needed update.
Oh, awesome. Okay. So is that something you can just apply and update, or is that
there's the apply the
Okay, don't have to reinstall anything, or.
Well, always back up your code.
Right.
Yeah, well, yeah, that's step one. Back up your code. Step two.
Yeah, that's the implied step one.
Right.
Yeah, but you never know. It's always good to restate.
Yes.
You got all levels of users out there, so.
That's
Yeah.
right.
Well, even if you've done it for a while, you forget sometimes. You just get comfortable and forget.
Become complacent.
And then you're like, oh yeah.
I've never done that.
Right.
How is
All right,
it? Okay, I was just going to say, how is it that hardware failures only come around after you've become complacent?
Right.
I've never once been like right on top of my backups and had a disk fail and go, oh yeah, no big deal. It's always the week where I go, I didn't do the backup this week. Oh no.
That's it.
Yeah.
That's you are absolutely right. It's there's some kind of law for that, right? Not Moore's law. It's a different one.
You're gonna go, he didn't do the backup this week.
Right.
There is a law for that. I think it's based off of people working in nuclear reactors, actually.
Wow.
I think it was what I read.
It's nuclear science.
Yeah, basically, the longer you work at a nuclear power plant, the less you're going to care about the safety, paying attention to the meters and stuff like that. Supposedly, it's the longer you do it.
Anything, we become complacent, right? We become too comfortable.
Become comfortable, exactly.
Right. All right. Well, thank you for sharing that, and Ed, thank you again for walking through and spending the time in the forums and sharing your knowledge with people, and we really appreciate it. And you guys, be back here next Monday. We're going to talk with the developers of FartWatch.
Wow. Okay.
Gotta let that one hang in there for just a second. FartWatch.
Look, there I'm laughing again. I'm so easy.
Yeah, it's it sounds a little bit childish, right? FartWatch, gonna make a fart app, another fart app. But it's a fairly, if you think about it, it's a fairly smart marketing attention grabber. Somebody's gonna make it, and we're gonna talk with them all about the platform and how it interacts and what they expect to see in the form factor and all those types of things. Because while Corona doesn't support it at the moment, it's an iOS piece, so you can imagine that at some point it probably will. So let's go ahead and have that conversation now and see what kind of plans they have for their app. And also, I'd like to see if they have any thoughts around monitoring your heart rate, maybe any sort of biometric rhythm kind of stuff. I mean, is this just strictly a fart app, or does it like track your farts? Or
Stop saying that.
oh, come on! Oh, you were thinking it. You knew you were thinking it. All right, so we'll be back.
Missed out on that gold rush.
We'll be back here next Monday, 12 p.m. Pacific, talking about that and and other things. So until then, have a great week and happy coding.
Take care.
Tschüss. Auf Wiedersehen.